Hello and welcome to this overview of Data Protector options. I'm Uli Waldscheid and I'm a product manager for Data Protector. And in today's episode, I will run you through our hypervisor support. Data Protector offers several ways of dealing with hypervisor-based data. So if you're hosting virtual machines on typical hypervisor platforms, you always have the chance and opportunity to back up via that hypervisor integration. Data is directly pulled from the virtual machine hypervisor stack, and usually this is done by creating a snapshot of virtual machines and then pull it off by certain backup APIs. With Data Protector, you also have the opportunity to back up individual items from within the virtual machine, and that's something that is not available by direct integration with the hypervisor. So we're leaving it a choice for our customers. We're using our backup integration agents to support the backup workflow and to support more granularity and even some more data consistency. Anyway, Data Protector and the Data Protector family offers you hypervisor-based protection and hybrid protection in both worlds. So the family consists of Data Protector itself and our new integration, Data Protector for Cloud Workloads, where Data Protector already came with VMware Hyper-V support and some scripted solutions like for KVM, Nutanix, and AWS EC2. And Data Protector for Workloads is now coming on board into the family to support all the remaining hypervisors where scripted solutions were used in the past or where we didn't have any kind of support statement at all. And in this presentation, I'm running you through especially those items that just came on board brand new. So let's start with OpenShift and OpenStack. OpenShift, OpenStack offer you kind of hypervisor virtualization in local and remote environments, even some of that running in the cloud. They have certain special requirements in terms of how resources are actually taken away. Backup APIs exist for various places, but they need to be combined to really make it a full-blown stack of backup integration. So OpenShift, OpenStack have certain different features and capabilities, and the Data Protector for Workloads integration makes use of all those backup APIs and integration elements. OpenShift, for instance, is more like a developer-centric platform which offers lightweight, automatic, and predictable way of deploying virtual environments. So that's a very important statement here. Virtual machines or containers are kind of ramped up and also shut down in the matter of seconds or minutes. So there is a certain potential that data can get lost, or just like for the sake of it, some historical data needs to be frozen to use it at a later point in time for whatever reason this may be. Most important is consistent data protection, making sure that all informations like files and applications are recoverable and all the data is consistent in itself. Our customers are asking for backup SLAs to give them the option to select appropriate backup policy and create optimal backup schedules. So this is done in an automated way, and it kind of supports the important way of data management. OpenShift has a certain internal structure, of course, usually made out of a manager element and so-called pods, kind of helper pods, that are used to address the data management of those containers. Data Protector for Cloud Workloads drives into those containers and into those APIs and extracts information via its Data Protector for Cloud Workloads node. And the node can either store that within a certain cloud environment, or it can forward to an enterprise backup provider. And this is where Data Protector is coming in to support OpenShift backups with all the backup infrastructure that is available on Data Protector main product. OpenStack is slightly different from that, but it follows kind of the same rules. It offers you to run certain applications or platforms, and it offers you a lot of flexibility for modern enterprises. It supports multi-tenant environments as well as customization and very good integration via its intuitive HTML5 web interface. So Data Protector for Cloud Workloads offers crash-consistent backup of those OpenStack resources. You don't need to worry about individual items here. All the usual standards used here are supported, like QCOW2, which is a kind of a format for storage capacity here, and also making sure that all the important APIs are used along the way of backup and recovery, especially when it comes down to where the actual data is sitting. This may be local or in persistent volume configurations. All of that is covered in the Data Protector for Cloud Workloads approach. Now moving over to generic hypervisors. This is where you would usually find vendors like KVM, Oracle VMs, AWS EC2, Nutanix, Citrix Zen, just to name a few. So please make sure that you check the support matrix and overview statements on our web pages for a full list and overview of hypervisors being supported. And this could be hypervisor manager approaches or individual hypervisors like shown here. So some of the individual features are listed, and I will dive into one or two of them in the next couple of slides. But how is this configured, and how easy is it to actually work with those hypervisors? Data Protector for Cloud Workloads will actually let you select from those hypervisor managers or from individual hypervisors. So it's a very easy and lightweight approach to get data from those systems. It is completely agentless and lets you select individual resources like the virtual machines or any surrounding information from those hypervisors. Now let's look at Nutanix AHV. In the past, Data Protector has supported that in a scripted kind of approach. Now we have a full-blown integrated approach into Data Protector for Cloud Workloads. Again, this is completely agentless. It's kind of remotely attached, and it supports the most important ingredients of Nutanix, especially when it comes to full and incremental backups of those virtual machines with certain kind of additional features being attached. It manages the snapshots to also improve better recovery point objectives, and it makes sure of a lot of storage technology kind of approaches like iSCSI, which is kind of a very flexible way of attaching this. So that's something that is very independent and gives you a lot of flexibility in the configuration. Data Protector for Cloud Workloads and KVM is pretty much going into the same direction. It makes sure that performance, data consistency, and typical backup and recovery features are available. For KVM, it is important to support the usual formats like disk formats, QCOW2, in both full and incremental kind of ways. And again, it is integrated with a very lightweight and intuitive HTML5 web interface. And yeah, the snapshot management of that is done by the usual APIs of the KVM implementation. Now, next up would be Oracle Linux VMs, pretty much comparable to what KVM does. Again, different standards here, sometimes different storage systems that are, or storage technology that is attached to the backend. Data Protector for Cloud Workloads makes sure that all this can be used in almost the same kind of way. There isn't that much difference in between configuring an Oracle Linux VM backup protection job compared to KVM or OpenStack, OpenShift. All of them have a lot of similarity, but underneath it may support different standards and kind of offers the features that they kind of come with. Last but not least, that's also Red Hat Enterprise Virtualization, also a very large and very important platform. Again, there are a lot of individual features that we need to support here. These can be more or less different from the previous ones. But again, we're making use of Data Protector for Cloud Workloads in a way that administrators can learn and use the procedures, the SLAs, and the jobs in absolutely the same way, even if the underlying infrastructure is slightly different. So the workflow itself is pretty easy and, like I said, pretty much universal to all the platforms that we just talked about. From a virtual environment instance point of view, you would select virtual machines to be backed up, and this can be individual virtual machines, of course, or all of the virtual machines. There are typical options available like searching for names or using tags to identify those virtual machines. And once you've done that selection part, you can send that data to any kind of the backup target that is available and also supported by either Data Protector for Cloud Workloads or Data Protector itself. Like in this example, it could be some local storage that is directly connected to the backup node. Could be the enterprise backup provider where data is routed to Micro Focus Data Protector. Or if you just want to leave the data in the same cloud, you may want to create a local cloud device like in Azure, AWS, or others, and then send that data to that local storage capacity. Now, in summary, Data Protector family now supports a large variety of hypervisors. So the total amount and the flexibility in hypervisors has largely grown. It can be virtual machines or containers, depending on the underlying hypervisor infrastructure. And you have the ability to back up and protect and also to recover them with the same workflows and the same shared storage and backup infrastructure. The bandwidth of capabilities address customers with hybrid IT consisting of physical, virtual, and cloud workloads, while at the same time, we're optimizing for cost and for maintenance efforts. Thanks for watching, and I wish you a nice day.